Welcome to Study Loop.
This is the problem number 18, and here we have to show that a e power ikx plus b e power minus ikx and c cos x plus d sin x are equivalent way of writing the same function of x, and determine the constant c and d in terms of a and b and vice versa. And the comments is given that in quantum mechanics, when v is equal to 0, the exponential term, that is e power ikx plus b power I minus ikx, represent the traveling waves and are most convenient in discussing the free particle. Whereas the sine and the cosine term, that is c sin x, c cos x plus d sin x, um, are used to in the infinite square wave. That is, they represent the standing waves. Let's write down this given e power ikx, e power ikx plus b e power minus ikx. Now I use the Euler formula to write this one. Let's this e power ikx can be written as cos kx plus I sin kx, cos kx plus I sin kx. Similarly, this can be written as b cos kx minus I sin kx, and we can separate this one cos part and the a cos x plus b cos x plus I a sin kx minus I b sin kx. If I take cos x common, that it can be written as the a plus b. Sorry, we take the cos x common here. It is cos kx plus, if we take the sin case common here, then it will be I a minus b and sin kx. Let's write this is the equation 1. If we assume that let a plus b is equal to c some constant, and this ia minus b, that is ib, is equal to another constant d, and now we solve this by multiplying by in this equation by I, that is it is ia plus ib is equal to ic. If we add this, then this part is cancelled, then it is 2 ia is equal to d plus ic, and from here we can find out the value of the a, that is a is equal to 1 by 2 and c minus id, and b will be, we substitute the value of the a in this any one equation, then you will get 1 upon 2 and c plus id. That means the given equation, this equation can be written as the c cos x plus d sin kx, that is a e power I kx plus b e power minus I kx can be written as c. So this is a plus b is the c, that is c cos x plus d, and this is d sine kx. So both are equivalent, but this this exponential term are mostly used in the uh, when the for the free particle, because you can read the comments. Yes, when v is equal to 0, the exponential represent the traveling waves. So it represent the in case of the free particle, these terms represent the traveling waves. So when you are discussing the free particle, that is particle in a box for free particle, then you will write the solution in this form. And if we are discussing in the some infinite potential, then you have to write the solution in this form. But both are the equivalent to each other. Thank you.